Now let's solve problem number 1.22 from this book. Let me read the problem for you. The velocity of particle moving in positive direction of x-axis. A particle is moving in positive direction of x-axis and its velocity varies as alpha root x. Means velocity is a function of displacement along x-axis. A particle is moving along x-axis and velocity is varying with x-axis, where alpha is a positive constant. Assume that at a moment t equal to 0, particle is at x equal to 0. Find the time dependence of velocity and acceleration of particle. They had asked us what is velocity as a function of time, what is acceleration as a function of time. Mean velocity of particle averaged over time that particle takes to cover the first s meters of path. Mean velocity over s meters. This is the problem. देखिए, velocity as a function of displacement, I can always write velocity as dx by dt. Velocity can be written as dx by dt, the rate of change of displacement along x-axis. Since the particle is moving along x-axis, I can rearrange this equation as 1 by root x dx is equal to alpha dt, and this can be integrated on both the sides. Alpha is a constant, integral sign से बाहर रहेगा. At time t equal to 0, x is 0, and at any instant t, it's x. Now, its integration is root x. One by x to the power half or x to the power half. This is x to the power minus 1 by 2. It's x to the power minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 or plus half. Alpha t from 0 to t and this from 0 to x. Or I will say this 2 root x is equal to alpha t, or x is equal to alpha square t square by 4. This is displacement as a function of time. This is displacement as a function of time. Now, we had asked with velocity as a function of time. In order to write velocity as a function of time, I will say velocity is dx by dt. I differentiate it with respect to time. So, this comes out to be alpha square t by 2. This is velocity as a function of time. Acceleration as a function of time. Acceleration is dv by dt. I differentiate this with respect to time, or it's alpha square by 2. The acceleration as a function of time. Now, mean velocity of particle averaged over the time, that is over the time that the particle would take to cover first s meters. अब देखिए, how do we define mean velocity? Mean velocity is defined as integral of v dt upon integral of dt, or this is delta s by delta t. अब फर्स्ट s मीटर्स ट्रेवल करने में कितना समय लगेगा वहां हम निकाल सकते हैं। हम कहते हैं एट t इक्वल टू 0, x इक्वल टू 0 एंड व्हेन x इज इक्वल टू s, दिस टाइम वुड बी, इसकी जगह मैं s लिख दूंगा 4s बाय अल्फा स्क्वायर, 4s by alpha square and under root of this is the time. Now mean velocity would be given as distance traveled is s minus 0 and time taken is under root of 4s by alpha square minus 0. So this comes out to be alpha by alpha root s by root 4, or you will say this mean velocity is alpha by 2 root s. So this are the answer to the problem. Once again मैं तेजी से प्रॉब्लम कंडीशन और उसके आंसर को तेजी से समझा देता हूं. अ पार्टिकल मूविंग अलोंग एक्स एक्सिस वेयर द वेलोसिटी ऑफ पार्टिकल वेरीज विथ एक्स एक्सिस अकॉर्डिंग टू दिस फंक्शन. इनिशियली at t equal to 0 particle is at 0. What is velocity as a function of time? What is acceleration as a function of time? And what is the mean velocity averaged over the first s meters of its travel? This is the problem. First of all, we wrote that velocity could be written as gx by dt because the particle is getting displaced along x-axis, and this gx by dt equal to alpha root x. I had rearranged this differential equation 1 by root x gx equal to alpha dt. I had integrated it on both the sides. This is integration. I put the limits. Limits is at 0, time t equal to 0, displacement is 0. At any time t, x is the displacement. So this is the equation that we get for displacement variation with time. I had differentiated in order to get the velocity. Velocity is gx by dt. हमने इसको differentiate कर दिया. In order to get acceleration, we had differentiated velocity with respect to time. dv by dt is acceleration, and this is acceleration. And mean velocity. Mean velocity is defined. It's denoted like this. It's defined as integral of v dt upon integral dt, or distance upon time. Total distance upon total time over the interval. At t equal to 0, x is 0. When it travels s meters, this would be the time. हमने x की जगह पर s लिख दिया 4s by alpha square और उसका अंडर रूट. This is the time. So mean velocity is distance s minus 0, time is final time minus initial time, and this is the mean velocity.